period by using the empirical formulas. The first empirical formula is number of stories divided by 10. So number of stories are equal to 3 divided by 10. So time period by using the approximate method is 0.3 second. Then by using the method A, we have to calculate the total height. The story height is 3.7 meter. So total height is 3.7 multiplied by 3. So this is the height of total height. And then we can multiply with the coefficient. This is the steel moment resisting frame. So this multiplying factor is 0.085. So by using the method A, the time period is 0.17 second. Then we can calculate the time period by using the method B of the UBC code. These are the stiffnesses of the different floors, stiffness of the first floor, second floor, third floor. Calculate the lateral displacement of the first mass at the first floor. So how can we calculate the lateral forces acting at this floor plus at all the floors which are above at this floor? So F1, F2, F3 divided by the stiffness of this floor, K1. So we can calculate the lateral displacement for this floor, this mass of the floor, and then lateral displacement of the second floor. Force acting at this floor plus the force acting above this floor. So F2 plus F3 divided by the stiffness of this floor plus the lateral displacement of the previous floor, delta 1. Lateral displacement of the third floor, F3. So we don't have any floor above this floor. So F3 divided by the stiffness of this floor plus the lateral displacement of the previous floor, delta 2. So in this way, we can calculate the lateral displacement of the different floors. Next, we can use this formula. In this formula, we have to have the summation of the product of the weight of the different floors and the square of the lateral displacement. And also in the denominator, we have summation of lateral forces and the lateral displacements of the different floors. So simply multiply the lateral forces with the displacements, take the sum, and we have this factor. Put the values, and we can calculate the time period. The value of the time period is 1.058. This building is in the seismic zone 3. And for the seismic zone 3, the time period calculated by the method B should be less than 1.4 times the time period calculated by the method A for seismic zone 1, 2, and 3. So apply this check. 1.4 times the time period calculated by the method A. The value is 0.724. This value should be less than 0.724. It's more than that. So the time period calculated by the method A, method B of the UBC code is 0.724. So in this way, we can calculate the time period for the structure by using the 3 methods. So just wait 1 minute. I'm just taking 1 minute. Okay, sorry, we will continue. Okay, any question? Can we calculate the time period by using the empirical formulas? It's easy, not so difficult. क्या ख्याल है? Taha, are you there?
Yes, sir. It's easy, sir.
समझ लग गया ना बेटा? Quite simple है.
Yes, sir.
So by using the empirical formulas, we can calculate the time period. Okay, then these two, how can we distribute the forces vertically once we have the value of the base shear? And how can we distribute the forces horizontally in the different frames? These two slides we will discuss later. Let's solve one example now. Because we have to use these two formulas, the distribution of the forces along the height and also the distribution of forces horizontally in the different frames. We have to use these formulas in this example. So it will be better that we will discuss at that time when we have to distribute the forces. So if you don't have any question, let's solve this example. We have the intermediate moment resisting frame and we have to find out the lateral forces. So this is the plan of the structure. How many grids we have along the x-axis? We have grid 1, 2, 3, 4, 5, and 6. So 6 grids along the x-axis, along the y-axis, and 4 grids along the x-axis, A, B, C, D. We have 2 frames along the x-axis, along the grid A and along the grid D. So this is the frame here, this is the frame here, and then we have 6 frames along the y-axis. 1, 2, 3, 4, 5, 6. So we have 6 frames here. They're given the names frame in the x direction, and this is the frame A along the grid A. This is the frame along the x direction, and this is along the grid D. Similarly, frame in the y direction along the grid 1, 2, 3, 4, 5, and 6. Okay. And this is the data. Number of stories, they are equal to 5. Story height is 3.5. Please note down these values because we have to use these values to calculate the weight of the structure. So number of stories, they are equal to 5. Story height is 3.5 meter. 28 days slender strength is 28 megapascal. Yield strength of the steel is 420 megapascal. The columns are square and the size is 500 millimeter. Beam size is 300 by 600. Width is 300, depth is 600. Thickness of the slab is 200 millimeter. Live load is 3 kilonewton per meter square. Superimposed dead load is 4 kilonewton per meter square. Perimeter wall weight is 3 kilonewton per meter. Importance factor for this structure, for this building is 1. Type of the soil is SC. We have to use UBC 97 provisions. Zone 2B. This building is in the zone 2B, and the zone factor for the zone 2B is 0.2. We can pick it from the table. And then the values for CA and CV. Again, we can see the values of CA and CV from the tables if we have the zone and the type of the soil. So these are taken from the table 16Q and 16R of UBC. So this is the data. Now calculate the weight of the building first. We will calculate the weight of one story as the stiffness and the mass for all the stories is the same. Material is the same, height, component, different dimensions, they are the same. So weight will be the same. So we will calculate the weight only for one story, and then we can multiply with number of stories. We will have the total weight of the building. So calculate the weight of the slab of any story. What is the thickness of the slab? It is equal to 200 millimeter. So 0.2 meter. We can multiply with the unit weight of the concrete. It is equal to 25 kilonewton per meter cube. So weight of the slab is 5 kilonewton per meter square. Let me open the same slide because Okay, this is the structure. Sorry. Then we can calculate the weight of the slab. What are the dimensions here? Along this direction, the total length is 5 multiplied by 5 panels we have here. So total length is equal to how much? 25 meter. Along this direction, the total length is 21 meter. So we have the weight of the slab per square meter. Then we can multiply with the area. 25 multiplied by 21. We can calculate the total weight of the slab. So 25 multiplied by 21 multiplied by 5. So this is the total weight. Then we can calculate the beams, weight of the beams. How many beams we have? We have 1, 2, 3, 4, 5, 6. 6 beams of size 21 meter each and 2 beams of size 25 meter. So 25 multiplied by 2 and 21 multiplied by 6. So 21 multiplied by 6 plus 25 multiplied by 2, and then size of the beam is 300 millimeter by 600 millimeter. We can subtract the thickness of the slab from the depth of the beam. So the remaining depth is 0.40. So 0.30 multiplied by 0.40. This is the cross section. And then we can multiply with the unit weight of the concrete. So we will have the weight of all the beams. So these are the number of beams, and this is the weight for one beam. So this is the weight for all the beams. Then calculate the weight of the columns. How many columns we have here? Anybody can count? कितने columns हैं?
24.
24 क्यों है बेटा? You're right, 24. 6 into 4, 24. You're right. So number of columns are 24. Thank you. Number of columns are 24. Length of the column. Story height कितनी थी? Story height was, I think, 3.7. You can subtract the depth of the beam. So remaining is 2.9. This is the length of the beam, the length of the column, 2.9. Number of columns are 24. Cross section is 0.5 multiplied by 0.5, 500 by 500 millimeter. And this is the unit weight of the concrete. So we have the total weight of all the columns, and then calculate the perimeter wall weight. Look at the perimeter. 25 multiplied by 2. Similarly, 21 multiplied by 2. So 25 multiplied by 2 plus 21 multiplied by 2, and the perimeter weight per meter is 3 kilonewton per meter. So we can have the perimeter weight, wall weight, and then superimpose dead load. So this is the area of the slab, 25 multiplied by 21. 25 multiplied by 21, and then multiply by the superimposed dead load is 4 kilonewton per meter square. Okay? So this is a total superimposed dead load. We can add all the previous values, all the weights of the different components, and we will have the weight of one story. So
Sir,
we can जी बेटा.
सर हमने स्लैब लोड पहले भी तो निकाला था, इससे पैसे ही सुपर इम्पोजिव.
That was a dead load, permanent dead load. This is a superimposed dead load.
So in difference क्या सर इन दोनों में?
That is the self weight of the slab, and this is, you can say, flooring. आपकी यानी आपका होता है ना floor thickness है, additional weight है. That was the thickness of the slab, self weight of the slab. And now this is a superimposed dead load.
Thank you, sir.
Okay,
Okay.
Clear.
Okay.
So we can have that weight of one story, and then we can multiply with the number of stories. We will have the weight of the structure. So we have calculated the total weight. This is the total weight. Once we have the total weight, next step is we have to calculate the time period. Definitely we can calculate the time period by using the empirical formulas. So this is the empirical formula, a method A of the UBC code. So this is a coefficient for the intermediate moment resisting frame. This is a concrete structure. Total height, story height is 3.5 meter. Number of stories, they are 5. So total height is 17.5. So we can calculate the time period. So this is a time period here. Next step is we have to calculate the base shear by using this formula. CV, we can see from the table, importance factor is given 1 for this example, for this problem. Response modification factor for the intermediate moment resisting frame is equal to 5.5. We can see from the table. Time period we have already calculated, weight of the structure we have already calculated. So we can calculate the base shear in terms of the weight, 0.32, and then importance factor is 1. Response modification factor 5.5, time period by using the method A of the UBC, that was 0.625, and this is the total weight of the structure. So base shear is equal to 0.093 W. ठीक हो गया? Next is we have to check the maximum and the minimum values of the base shear. So base shear should not exceed this value. Again, put the values. This value is greater than the maximum limit is, it should not exceed. So maximum limit is this one. It's more than the calculated value from the first formula. So it's okay. Again, the base shear should not be less than this value. So this value is less than the value calculated from the previous formula. Again, it's okay. So base shear is equal to 0.093 W. Just multiply with the weight, which we have already calculated. So this is the total base shear, total lateral force at the base of the structure. Time period is 0.625, which is less than 0.7 second. If the time period is less than 0.7 second, then the additional force at the top level is equal to 0. But if it is more than 0.7 second, then we have to apply the additional force at the top level by using the empirical formula वो हमने देखा था पहले, if you remember, FT. ये यहाँ पे होना चाहिए, यहाँ पे ठीक हो गया. FT is equal to 0 if the time period is less than 0.7 second. If FT is equal to this value if the time period is greater than 0.7 second. Okay. So in our case, for this example, time period is less than 0.7 second. So additional force as per UBC code that is equal to 0. So this is the total base shear at the base of the structure. So we have calculated the base shear. Once we have the base shear, the next step is we have to distribute the forces. We have to calculate the lateral forces, which are to be applied at the different levels by using the lateral distribution formula. Now we will discuss the lateral distribution formula. So by using this formula given in the code, we can distribute the forces along the height. V is the base shear, Ft is the additional force which is to be applied at the top floor. So by using this formula, we can calculate the lateral forces at the different level. V minus Ft multiplied by Wx. Wx is the weight of the different floors. Hx is the height of that floor from the base. Similarly, in the denominator, we have the product of weight and the height of the floor. Weight is the Wi is the weight of the different floors. Hi is again the height from the base of the different floors. So Fx is the design seismic force which is to be applied at the different floors. Wx is the portion of the weight which is to be assigned at the level X. Wi same. It is the weight of the different floors. Hx and Hi. These are the heights of the different floors from the base. So let's use this formula to calculate to distribute the force vertically. So this is the formula. So in the denominator, we have the summation of the product of the weight and the height of the different floors from the base. Wx, because weight is same, it's constant for this symmetrical building, it's same value. So we have Wx into H, Wx into 2H, Wx into 3H, Wx into 4H, and Wx into 5H. Wx we can take outside. So we have 15 Wx here. In the numerator, V minus Ft. Ft is 0. So here again, it's a typing mistake. You should have to add V here. OK, please add V here. Wx and then Hx. Hx is the height of the floor, typical floor, for which we have to calculate this lateral force. So in general, we can say this is Xh. X is the number of story, a number of. OK, this is the number of story. For the first story, the height is 1h. For the second story, it will be 2h. For the third story, it will be 3h and so on. So please add V here because Ft is equal to 0. Wx will be cancelled. H will be cancelled. In the denominator, we have 15 multiplied by V. ठीक हो गया. And in the numerator, we have the number of story. For the first story, this value will be equal to 1. For the second story, F2, this value will be 2. OK, and so on. So we have simplified this expression. This is only for this particular case. But if your building is not symmetrical, story height, stiffnesses, weights are different for the different stories, every time you have to use the same formula, this basic formula. But for this case, we have simplified this expression so that we can easily calculate the lateral force for the different floors. Any confusion about this formula? Any question? बड़ा clear है आपको?
Yes sir, clear है.
इस केस के लिए हमने इसको सिंप्लीफाई कर लिया. Otherwise, every time if the story weight and the height are different, so every time you can use this formula. Okay, so for this particular case, the lateral force is equal to x over 15 times V. X is the number of story. So we have the weight of the different floors. It's same for each floor. Height from the base for the different floors: 3.5, 7, 10.5, 14, 17.5. Then we have the product of weight and the height. Because if the story height and the weights are different, then this table is very useful. But in this particular case, I think there's no usefulness of this table. Anyhow, this is a format. By using this kind of table, you can easily distribute calculate the forces at the different levels. So general expression which we have is x over 15 times V. So for the first story, it is 1 over 15. For the second story, 2 over 15, 3 over 15, 4 over 15, and 5 over 15 times the total base shear. Now, please tell me if you will add these lateral forces at the different levels, answer should be equal to किसके बराबर होना चाहिए? The sum of all the lateral forces, including the additional lateral force, that should be equal to base shear के बराबर. इन सबको add करेंगे, answer should be equal to the base shear. You can check it. So is it clear? कोई confusion नहीं है? If you don't have any confusion,
yes sir, clear.
Then we can because if you have to perform the static analysis manually, then you need the lateral forces at the different frames. OK, definitely you can apply at the center of the stiffness these lateral forces, and you can perform the three-dimensional analysis if you want. But if you have to find out the response manually, then you have to distribute the forces in the different frames. So we have how many frames along this direction, along the y direction, along the x direction? We have 6 frames. 1, 2, 3, 4, 5, 6. 6 frames along the y direction and 2 frames along the x direction. Let's see that. And the formula to calculate the share of the base shear in the different floors is this one. This is the base shear in the y direction in any frame. We have 6 frames. In this particular case, because stiffness, mass, everything is the same. So we have uniform distribution of the forces, lateral forces. Sorry, not the lateral forces. We have to calculate lateral forces later on. This is the base shear at the base of each frame. So this is the stiffness of the particular frame I divided by the stiffness of all the frames in that direction. Then the base shear in that direction plus minus the stiffness of the frame in that direction multiply by xi. Xi is the distance from the frame to the center of stiffness of the floor. This one we will discuss later. Divided by torsion stiffness multiplied by the total base shear in that direction, and E is the eccentricity. First, we will assume the load is along the y or the x direction. So this factor will be equal to 0. If the eccentricity is equal to 0, this factor is equal to 0. So we will use this part of the formula only. So this part is stiffness of that floor divided by the total stiffness of the floor. Okay? Suppose we have the same base shear in the two direction. So this is the value of the base shear 2773. So if you will use that formula, base shear at the base of each frame, that is the stiffness of that frame divided by the total stiffness in that direction. So how many frames we have in the y direction? कितने frames हैं y direction में? Count कर लें बेटा. 1, 2, 3, 4, 5, 6. कितने हैं? Nobody is responding.
X direction नहीं है.
बेटा ये y direction, ये वाला. इसकी बात करें. 6 है.
Yes,
So in this direction we have 6 frames. So if you have to find out the shear of the base shear at the base of this frame, okay? So that the formula to calculate the base shear at the base of this frame, that will be equal to stiffness of this frame divided by the stiffness of all the frames. So stiffness of this frame is K. All the frames have the same stiffness. So K divided by 6K multiplied by the total base shear. ठीक है? यही होगा. अब ये देखें. K divide, इसको simply आप divide कर लें. ठीक है? K divided by 6K multiplied by the base shear. Similarly, in the x direction we have two frames. Their stiffnesses are same. So stiffness of the frame in the x direction divided by the total stiffness is 2K. K divided by 2K. We have only K here, 2 here, multiplied by with the V. So for this frame, this is the base shear in each frame in the y direction, and this is the value of the base shear in each frame in the x direction. We have simply divided, equally divided, because stiffness is the same. If the stiffness is different, then you can calculate by using the formula which I've shown to you. ठीक हो गया? Any confusion? Once we have the base shear at the base of each frame, so can we distribute the forces vertically along the frame? इसकी बेस पे अगर आपके पास बेस shear है, ठीक है, इस फ्रेम में, so along the height can you distribute the forces? Again we have to use the same formula for the vertical distribution of the forces. जो formula हमने पहले किया ना, वही हमने formula use करना है. Which formula? This formula again. Again, if you will simplify for each frame, you will have the similar expression x over 15 into v, and now v is the base shear at the base of each frame. Okay, again we can distribute vertically along the frame by using the similar procedure. ठीक है? So क्या formula था? X over 15 into v, and base shear in each frame, that is equal to 462. So 462 multiplied by x over 15. So you can calculate the base shear along the height. ठीक है जी? Again, if you will sum up all the base shear, that should be equal to the total base shear in that direction. Okay. Similarly, if you will total base shear in that direction, that particular frame. Similarly, if you will add all the base shear in a particular frame, all the lateral forces, that should be equal to the base shear in that frame in the x direction. Clear है? कोई issue है? अभी हमने क्या किया है? By using the horizontal distribution formula, we have distributed the forces horizontally in the different frames, and once we have the lateral force, base shear in each frame, we can again distribute vertically in that particular frame by using the same formula. हमने हॉरिजॉन्टली डिस्ट्रीब्यूट किया है ईच फ्रेम में, फिर वर्टिकली डिस्ट्रीब्यूट किया, वही फॉर्मूला यूज किया हमने जो पहले यूज किया था. एनी क्वेश्चन? एनी क्वेश्चन?
सर.
क्लियर है ना? उसमें हमने पूरी बिल्डिंग में किया था पहले, ठीक है ना? सेंटर ऑफ स्टिफनेस में हमने अप्लाई की फोर्सेस. अगर आपने मैन्युअली कैलकुलेट करना है, इफ यू हैव टू फाइंड आउट द रिस्पांस मैन्युअली, देन डेफिनेटली यू नीड द फोर्सेस टू बी अप्लाइड एट अलोंग टू डायमेंशनल एनालिसिस करना है आपने, हर फ्रेम में कितनी आएगी. सो फर्स्ट यू कैन डिस्ट्रीब्यूट द बेस शेयर इन ईच फ्रेम सेपरेटली एंड देन यू कैन डिस्ट्रीब्यूट वर्टिकली. ठीक हो गया? ओके, I have one question. What do you think? The earthquake will always be along the x or the y direction? Whatsoever is the orientation of your structure is. क्या ख्याल है? If you have the x and the y direction for particular structure orientation, so along earthquake along perpendicular or parallel to that direction always?
No, sir, it would be unpredictable.
Unpredictable. You're right. Earthquake can be in any direction. It's not in your control. It's unpredictable. You're right. So court has suggested something that you have to calculate the base shear. Sorry, you have to calculate the base shear when the earthquake is not parallel to x of the y direction. It is at some eccentricity. Okay. Provisions you can calculate the response of the structure when the earthquake is at 5% eccentricity, at 10% eccentricity. Okay, so how can we calculate the lateral forces or the base shear? No, lateral forces when the earthquake is not along x or the y direction. Again, we can use the same formula. वो फॉर्मूला देखिए जरा, मैं इसको आपको दिखाता हूं जरा. This is a vertical distribution. This is the horizontal distribution. Okay, this is the horizontal distribution of the forces in the different frames. Stiffness of that frame divided by the total stiffness of the frames, all the frames in that direction, multiplied by the total base shear. And look at this part now. Suppose the earthquake is at some eccentricity. E is the eccentricity of the earthquake, and xi is the distance from the frame to the center of stiffness of the floor. And this is the stiffness of that particular frame, and Kt is the torsional stiffness. Torsional stiffness you can calculate by using this formula. Sum of the product of stiffness of all the frames in that particular direction multiplied by the distance from the frame to the center of stiffness of the frame. Okay, in the x and the y direction. So we have to use this formula to calculate the torsional stiffness. Sure. Suppose the earthquake is at 5% eccentricity. Okay, in the y direction, parallel to the Fy1 and Fy6 frame, then in the y direction. Look at this frame again. Okay, we have to calculate the base shear in the frame 1 and in the frame 6 when the earthquake is at 5% eccentricity. Calculate the total stiffness. Again, the total stiffness will be equal to 6K, K plus K plus K. We have 6 frames, stiffness for each frame is the same. So this will be equal to 6K. Eccentricity, total length is 25. The earthquake is at 5% eccentricity. We can calculate the value of E, 1.25. And then calculate KT. KT, we have to calculate the stiffness. Now KT is equal to ये इस पे देखते हैं. Stiffness of that frame multiply by square of the distance from the frame to the center of stiffness of the frame. ठीक हो गया? The floor. Okay जी. Look at this figure. This is a symmetrical building, and this is the center of stiffness of the structure of the frame. Okay, center of stiffness of this complete building. This one. What is the distance from this center to the center of this frame? कितना है? यहाँ से लेके यहाँ तक distance.
2.5 meter.
2.5 meter. You are right. And then distance of this frame from the center of the stiffness of the floor. ये कितना है? यहाँ से लेके बड़ा यहाँ तक कितना है?
7.5.
7.5. And then distance from the center of the stiffness of the floor to this frame.
12.5.
12.5. So we have 2.5, 7.5, and 12.5. How about on the other side? 2.5, 7.5, and 12.5. Agreed? यही है ना? 2.5, 7.5, and then 12.5.
Yes, sir. Yes, sir.
Okay, right. You agreed. So stiffness of the ये कौन सा frame है? Stiffness of this frame multiplied by xi square. Stiffness of this frame multiplied by x2 square. Stiffness of this frame multiplied by x3 square. ठीक हो गया जी? So 2.5 square stiffness is same for each frame. K1 x1 square plus K2 x2 square plus K3 x3 square. And for the frames which are on the other side, x1, x2, x3, they are the same, 2.5, 7.5. So simply we can multiply it with 2. So we have the torsion stiffness. Okay? By using this formula. This formula. This is the summation of the product of the stiffness of each frame and the distance, square of the distance from the center of the floor to the frame. Once we have the value of KT, then we can put in the formula. So we have the we have to calculate the stiffness. We have to calculate the base shear in this frame and in this frame. For the other frames, you can calculate yourself. So we are going to calculate the base shear only in this frame and in the last frame when the earthquake is at some eccentricity, 5% eccentricity. So calculate the base shear in the frame 1 and 6, okay, which are at the ends. Stiffness of the frame 1 divided by the total stiffness, we have this value 6K, total base shear plus K times XI. For this frame, XI is 12.5. Value of KT, torsion stiffness, total base shear multiplied by E. E is 1.25. So we can calculate this value. This is 0.203. And when you multiply the total base shear in this direction, so the base shear in the frame 1 and 6, that is equal to 563 kilonewton. Previously, it was 462 kilonewton. So base shear is increased. It's changed. When the earthquake will be at some eccentricity, the base shear value is changed. Okay? It will be 22% more than when the earthquake is not at some eccentricity. Any confusion, any question? For the other frames, for this frame 2 and 3, you can calculate. Only difference will be this value will be different, 7.5 and 2.5. Remaining will be the same. ठीक हो गया? So any question?
हम हमेशा 5% eccentricity assume करेंगे y direction में.
Code में given है. You have to calculate
okay,
at 5% eccentricity at 10% eccentricity. These are the code provisions. ठीक है? Because